Hi all, this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. The topic name is Electro Discharge Grinding Problems and Solutions. Right. At the end of this session, student will be able to solve the problems on material removal rate of electro discharge machining. Okay, right. Now, before we discuss the problems, let us see the non-traditional machining process. So, under that, mechanical, thermal, chemical, and electrochemical. So, under mechanical, ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. Under thermal, electro discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining. Under chemical and electrochemical, chemical milling, plasma chemical machining, photochemical machining, electrochemical machining. Now let us go to the problems of electro discharge machining. In an EDM, okay, EDM stands for electro discharge machining. Okay, in the first problem, the following data is given: discharge current 15 amperes, pulse on time 100 microseconds, pulse off time 50 microseconds, specific removal rate, that is 1.5 into 10 power minus 3 mm³ per ampere per second. Okay, now calculate the material removal rate in mm³ per minute. So this is the first problem. Okay, as I said earlier, some superfluous data may be there, but that data can be used for the assessment of other parameters. But in order to calculate the material removal rate, all the given data may not be useful. Okay, right. See here, the material removal rate in EDM, electro discharge machining, can be calculated using this formula. Okay, MRR, material removal rate. Okay, so that is C dot I into T on by T on plus T off. Okay, so what is I? I is the discharge current. Okay, T on is the pulse on time. T off is the pulse off time. C star is the specific removal rate constant. Okay, right. So I equal to 15 amperes given, T on equal to 100 microseconds, T off equal to 50 microseconds, and C star is given as 1.5 into 10 power minus 3 cubic meters per ampere per second. Okay, so this is the given data from the problem. Now let us look at this. Okay, 50, 100, 50 and 1.5 into 10 power minus 3. Okay, so every data is given, so we need to just substitute in this formula duty cycle. Okay, first let us find the duty cycle. Okay, T on by T on plus T off. Okay, so after substitution we get this 2 by 3. Okay, right. Now let us calculate material removal rate, that is 1.5 into 10 power minus 3 into 15 into 2 by 3. Okay, so this 2 by 3 is the duty cycle and this is C star. Okay, see, look at this. Okay, C star into I, okay, C star into I. This is C star value, this is I value. Okay, this is duty cycle, that is T on by T on plus T off. So finally we got 0.015 cubic meters per second. Okay. Now convert to mmq per minute, so that we get MRR. Okay, 0.9 mmq per minute. Okay, thus the material removal rate is 0.9 mmq per minute. Okay, right. Problem 2. Tool wear ratio in EDM. Okay, in an EDM process, the following parameters are observed. Okay, volume of material removal from the workpiece, that is 20 mmq. Volume of material removed from the tool, that is 5 mmq. Calculate the tool wear ratio. Okay, so here tool will be on top and workpiece will be on bottom. Okay, so the formula for TWR is just volume of material removal from the tool, that is this one, by volume of material removed from the workpiece. Okay, now let us look at here. Okay, and in percentage, that is into 100. Okay, so that 5 by 20 into 100, that is 25 percentage. Okay, so the TWR is the 25 percentage. Okay, right. Now problem 3. Power consumption in electro discharge machine. In an EDM process, the following data is provided. Okay, discharge voltage 100 volts, discharge current 20 amperes, duty cycle 60%. So calculate the average power consumption in watts. Okay, right. So for power consumption, the formula is V into I into duty cycle. So V is given and I is given, and duty cycle is 60%, that is 0.6. So simply substitute the values V, I and duty cycle. Okay, so V given as 100, I given as 20, and the duty cycle is 60%, that is 0.6. So that we get 1200 watts. Okay, thus the average power consumption is 1200 watts. Okay, right. Now let us look at problem number 4. Spark gap in EDM. Okay, in an EDM process, the following data is given. Open circuit voltage is given, discharge voltage is given 100 volts, and capacitance of the dielectric, that is 500 pm. Okay, right. Calculate the energy per spark. The spark gap distance is 0.02 millimeters. Okay, right. Now the energy per spark E in EDM can be calculated using this basic governing formula, E is equal to half CV square. Okay, where C is the capacitance of the dielectric, V is the discharge voltage. Okay, so here C is given as 500 pm, that is 500 into 10 power minus 12 F. Okay, so V equal to 100 volts. Okay, now substitute the values simply. Okay, E is equal to half CV square. Okay, C is given as 500 into 10 power minus 12. Okay, V is given as 100. So finally that it will be in joules. So finally we can convert into microjoules. Okay, so thus the energy per spark is 2.5 microjoules. Okay, right. Right, estimating machining time in electro discharge machining. In an EDM process, a hole of diameter 2 mm and depth 5 mm is to be drilled in a material with the following parameters. MRR, material removal rate, is 0.8 mm³ per minute and overcut is 0.1 millimeters. So calculate the time required to drill the hole. Okay, right. Solution. First calculate the volume of the hole. Okay, so volume of the hole is pi into d plus 2 times the overcut whole by 2 and whole square into h. Okay, so here d is given 2 mm. Okay, look at this in the problem. 2 mm diameter 2 mm is given. Okay, and overcut 0.1 mm. Okay, in the problem overcut is given. Okay, and h 5 mm. Okay, so here depth is nothing but height. Okay, that is also given. Okay, 5 mm. Now simply substitute these values. Okay, so that we'll get the volume of the hole. So here first we have to find out the volume of the hole by using this formula. Okay, so this one is the formula, pi into d plus 2 into overcut whole by 2 whole square into h. Okay, right. So substitute the values in that formula so that we get volume of hole equal to this one, pi into 1.21 into 5, that is 3.8 into 3.1416. That is, this is the value of pi. So totally the value is 19.1 mm³. Now calculate the machining time. Okay, we have the formula MRR equal to volume of hole by machining time. Okay, so this much volume of hole means volume of material removed. Okay, so in other words machining time we need to find, so volume of hole by MRR. Okay, so 19.1 mm³ by 0.8 mm³ per minute. So finally we get the time in minutes. Okay, so that is 23.875 minutes. Okay, thus the time required to drill the hole is approximately 23.88 minutes. Okay, so the answer is 23.875. We rounded it to 23.88 minutes. Okay, right. Right. So with this, let me reiterate certain points. Okay. So in the problem 1, the material removal rate, the formula is this one. Okay, just I wanted to summarize. Material removal rate equal to C star into I into T on by T on plus T off. Okay, so where C star is the specific removal rate constant, I is the discharge current, and T on off are the pulse on time and pulse off time. Okay, right. Next, in the second problem, TWR, that is tool weight ratio. Okay, it is the ratio of volume of material removed from the tool to the volume of material removed from the workpiece. Okay, so TWR equal to volume of material removed from the tool. Okay, volume of material removed from the workpiece. Okay, so we have to understand that material removal will be taking place from the workpiece as well as the vibrating tool. Okay, right. Not vibrating tool, electro discharge machining tool. Okay, right. Now look at this. In the third problem, in order to find the power consumption, V into I into duty cycle. Okay, if the duty cycle is given in the percentage, then just we have to substitute. Okay, let us say if it is given as 70%, 70 by 100. Okay, and volume and what is that? Voltage and current will be given in volts and amperes. Okay, so that we will get the power in watts. Okay, right. Next, in problem number 4, see here we need to calculate the energy per spark. Okay, so for that the formula is that of CV square, where C is the capacitance of the dielectric, V is the discharge voltage. And don't forget that you need to convert 500 PF into just in F. Okay, so PF means 10 power minus 12 F. Okay, so that conversion we have to follow. Okay, and just substitute the values, and finally we have to convert this joules into microjoules. Okay, so here 10 power 6 is nothing but microns. Okay, right. And in problem number 5, here diameter and depth, that is nothing but height, the hole, drilled hole. Okay, suppose in the workpiece, suppose if we remove, okay, with certain height or depth and diameter d, then we have to find the time required to drill the hole. Okay, so here hole has been made, but for that we need to find the machining time. Okay, for that first we have to find the volume of the hole. Once if we get the volume of the hole, then we can find the time taken to machine that hole. So by using this formula, pi into d plus 2 times overcut by 2. Okay, so here overcut is 0.1 mm. Okay, so that is what we have to take care in the problem, right? So once if we get the volume of the hole, and we can find the machining time. Why? Because already we know material removal rate, MRR, equal to volume of hole by machining time. Okay, so MRR equal to volume of hole or material removal, volume of material removal by the machining time. Okay, so just move this, then we can find the machining time. Okay, right. So substitute all the values so that we'll get the, so this is the reference. So with this we can conclude this one. Okay, so with this, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.